In this video, we'll talk about trig substitution. There are three formulas which you need to be familiar with under trig substitution. The first one is the integral of the square root of a squared minus x squared dx. The second one is the integral of the square root of a squared plus x dx. The third one is the integral of the square root of x squared minus a squared dx. Okay, so now under these formulas which we have come up with, the three formulas, we need to understand that a is constant. Okay, we need to understand that a is constant. Now, the first formula, where there is x, we are going to be replacing with a sine theta. The reason for this is because we know that 1 minus sine squared theta is equal to cos theta. Okay, we know that 1 minus sine squared theta is equal to cos squared theta. Okay, the second one we are going to be replacing here with, where there is x, we are going to be replacing a tan theta, tan, or not tan squared, sorry, but just tan theta. The reason for this is because we know that 1 minus, or 1 plus tan squared theta is equal to sec squared theta. The third one, where there is x, we are going to be replacing with what? With a sec squared, sec theta, sorry. The reason why we are going to be replacing sec squared, sec theta, is because we know that sec squared minus 1 is tan squared theta. So we need to be familiar with these formulas. Now, how can we solve a question under trig substitution? Let's see what's going to happen. Okay, let's say we have the question which is the integral of, then we have the square root of 4 minus x over x squared dx. Now, there is no any other method which we can use to solve this question apart from trig substitution. And how do we do that? So here, this question, I'm supposed to put squared there. Now, if we can check this one, we can only use the first formula, because the first formula we said the integral of the square root of a squared minus x squared. So this guy which we have here resembles that. Okay, now what are we going to do? Let's start. We know that a squared is 4 in this case, because we said a is constant. What of a? Our a is going to be 2. Okay, what of x? We said x we are going to be replacing with a sine theta when we have got this formula. But now what is our a? Our a here is 2, so it's going to be 2 sine theta. Now let's differentiate this function. Okay, so if I want, I can put them, let me put them there. So we're going to have x is equal to 2 sine theta. What of dx? Let's differentiate this function which we have there. So if we are to differentiate this function, what we're going to have is going to be, you know that the derivative of sine is cos. Okay, so it's going to be 2 cos theta, but we are differentiating this in terms of theta, so it's going to be times d theta. We are done with that. Let's now start now solving. The integral of the 4 doesn't change because it is constant, but what's going to change is on x. Where there's x, we're going to replace with it. So we're going to do, since it is squared, we are going to say 2 sine theta, we square it, divided by, again, 2 sine theta, we square it, times, where there's the x, we're going to put in what we have there. Where there's x is going to be times 2 cos theta d theta. There we go. So from there, what else do we know? We're going to say the integral of, we are going now to 2 sine theta, then we have got squared outside, same as it's going to be 4 sine squared theta. Same applies to what is going to be down there. It's going to be sine squared theta. Here we have got 2 cos theta d theta. The 2 which we have here can go with the 2 there, then there we're going to mean with 2. But at the same time, we can factor out what is inside because we have got the 4 which is common. So what are we going to do now? What we're supposed to do there is it's going to be the integral of, we're going to factor out 4 open bracket 1 minus sine squared theta divided by 2 sine theta squared. Then we have times cos theta d theta. Okay, we can start it from there now. So what's going to happen? We have got 4 inside there, guys. Okay, we have got 4 open brackets 1 minus sine squared theta. Now that 4 is the same as if I have the function the square root of 4 times the square root of 1 minus sine squared theta, which is the same as if I can just get the square root of 2, I put them as 2, then I put them there. Okay, it's the same, right? So if that is the same, then we can now conclude to say we can have the integral over, inside there I'm going to factor out, it's going to be 2 now because the square root of 4 is 2, so it's going to be 2 the root of 1 minus sine squared theta, everything divided by sine squared theta. So there we have also 2. So then times cos theta d theta. Okay, cool, perfect. Now from here we can also see that the 2's can go. So if the 2's can go, then what we're going to remain with is the integral of the square root of 1 minus sine squared theta divided by sine squared theta times cos theta d theta. We know that 1 minus sine squared theta is the same as 1 minus sine squared theta is equal to cos squared theta, meaning I can replace where there's 1 minus sine squared theta with cos theta. Okay, so if I want to do that, then I'll come there and say the integral of the square root of cos squared theta over sine squared theta times cos theta d theta. Let's create space on top there. Okay, now after that, what else do we know? Let's continue. Now what we have there is what we have there down now there is what? We know that the square root of, it's the same as 4, the square root of 4 is 2. So what is the square root of cos squared? It's just cos. So the integral of cos theta over sine squared theta divided by cos theta d theta. So now that is the same as cos times cos is going to be cos squared theta over sine squared theta d theta. Now here what we're supposed to do is this. We can't solve it direct. It's going to be complicated. What we should know here is this now. Okay, what we should know here is this. We can also replace where there is cos squared with 1 minus sine squared theta. Okay, so the integral of is going to be 1 minus sine squared theta over sine squared theta d theta. The function which we have now there, you can agree with me to say it is the same as if I have 1 plus 2 over 3 is the same as 1 over 3 plus 2 over 3. So that what we have there is the same as if we are going to have, if I separate it, then we have the integral of 1 minus sine squared theta minus sine squared theta divided by sine squared theta. We put them in brackets. Okay, d theta. 1 over sine is what? We know that 1 over sine is cosec. Okay, so we continue from there. 1 over sine is cos squared theta minus sine squared theta divided by sine first theta, we are going to get 1. So we can put them in brackets and we say d theta. Okay, now let's integrate. Let's now integrate. What is the integral of cosec? So the integral of cosec is, we know that the derivative of cot, the derivative of cot is what? Negative cos squared, cosec squared theta. So now what of the integral of cosec? So the integral of cosec is negative cot theta minus, here we're going to have theta. Okay, so we know that we're supposed to include C. But are we done with the answer? No. We started with the x. We are supposed to go back to our x because these are just helping us to find the answers. So now what we're going to do is this. The first guy which we made as x is the one which we are using. So we're going to make that guy, we're going to have there. We made x as 2 sine theta. Let's solve for sine theta. We're going to divide by 2 and we're going to have sine theta is going to be x over 2. Now let's make our triangle because we're dealing with trig now. So we're going to have our theta there and we're going to have 90. And we know that sine theta is equal to opposite. So opposite is this one and this over hypotenuse. Hypotenuse is that one. So we can say that this is C, this is A, this is B. So now let's see. C squared is equal to A squared plus B squared from Pythagoras theorem. Then we know that C is 2. So it's going to be 2 squared is equal to A is x squared plus B squared. So this one is going to be 4 minus x squared is equal to B, meaning B squared. So now if we want to solve for B, it's going to be B, the root of 4 minus x squared. So now we know that the hypotenuse now here is just basically the root of 4. Okay, we know that it's going to be the root of 4 inside there minus x squared. Okay, for now, after knowing that, what else are we supposed to do? Okay, what else are we supposed to do? After knowing that, we know that cot theta is the same as 1 over tan theta. Therefore, we are supposed to solve for tan theta. So what is tan theta? We know that according to Sokatoa, tan is opposite of adjacent. So our opposite is x. So we can get rid of this because we know that now that can get rid of this. We know that tan is what? So we're going to say tan theta is going to be the opposite over adjacent. The opposite is x over adjacent is the root of 4 minus x squared. Okay, now this is the tan theta, but what is cot theta? Cot is just the opposite of tan. So we are going to say cot theta is going to be 1 over the tan. So tan is this one. So if you've got this fraction over 1, it's the same as if we can just exchange them on top there. Then we say the cot is going to be the root of 4 minus x squared over x, meaning this is our what? Our cot. But now we have got that function there. Let's check. Let's get rid of this. We have this. We made. Now, if I can remove that side, now we have, as our final answer is now coming as negative the root of 4 minus x squared over x. But again, we have got minus theta there. We don't want theta, we want to return back to our x's. So we are going to have, let's now solve for theta here, this equation. Let's solve for theta. What are we going to do? Theta is going to be sine inverse, open bracket, x over 2. Meaning where there's theta, we're going to replace with what? So we can do this. We can write it from there. We say the final answer is negative the root of 4 minus x squared over x minus sine the inverse x over 2. Now there we need to include c. Okay, plus c. So this is the answer. for this question. Okay, let's solve the next question. Let's solve the next question. So the next question which we need to solve is it's going to be a bit complicated, but we are going to do it because we are here together. Okay. Okay, now the next one is what we're going to have is the integral over not this one. If I give you this one is very, very simple. Let's solve the complicated one. Okay, the next one is going to be 1 divided by the root of x squared minus 4 dx. If we can remember very well, we had a similar formula which we had x squared minus a squared. So meaning this is the same, right? So if that formula is the same, what are we supposed to replace with x? That is the last formula which I gave you. Meaning where there is x, we're supposed to replace with what? A sec theta. Okay? So now we can start now there. Let's now remove that. We can start and we are going to say our a is 4. Our a squared is 4. What of a? Our a is 2. Okay? So if our a is 2, then what of our x? Our x is going to be 2 sec theta. What of dx? What is the derivative of that guy? The derivative of sec is, we can put it here. The derivative of sec, can put dx of sec is just basically tan theta sec theta. The what? The theta, because we're differentiating it in terms of theta. Now let's start now plugging the values. The integral of 1 divided by the square root of, we have the square root of, where there's x, we are going to have 2 sec theta, but everything is squared, minus 4 times what of the x is 2 tan theta sec theta d theta. Let's continue. Now from here, what else are we supposed to do? Now from here, we can factor out what is inside there. So we are going to have 1 divided, but this is the same as if I can just multiply 1 by what we have there, 2 tan theta sec theta. So we are going to have 2 tan theta sec theta over, inside there we are going to have 4 sec squared theta minus 4 then d theta. Now what we need to discover here is that inside there always we are going to find that inside the square root we are going to find that there are numbers which we are going to factor it out, and that number is going to have the square root. Always the constant which is going to be there is going to have the square root. It's going to have the root. Okay, now let's continue. If we can factor what is inside there, on top there will remain with it tan theta sec theta, then divided by, I'm going to factor out 4. So it's going to be 4 open brackets sec squared theta minus 1 d theta. Okay, then from there I can continue from here. Then we are saying it's going to be the integral of 2 tan theta. On top there I'm just copying the way it is, tan theta sec theta over, now what we have there is the same as the example which we had previous. So 4, the square root of 4 is 2, so I'm going to put 2 outside. The root of sec squared theta minus 1 then d theta. The 2's can go because they're the same, so we're going to cancel 2. After cancelling 2, what we are remaining with is the integral of tan squared or tan theta sec theta over the root of sec squared minus 1 d theta. If you can remember very well, we know that sec squared theta minus 1 is the same as tan theta, tan squared theta. I said that earlier. So we are going to replace now that. We are going to have tan theta sec theta divided by what? Here we're going to have the root now. It's going to be tan squared theta d theta. Okay. Now, after knowing that, we know that the square root of tan. What is the square root of what? Tan squared. It's just tan. Okay. Then we're going to have the integral of, on top there remains the same, sec theta divided by, here now we're going to have tan. On top there we're going to have tan theta d theta. We can also clearly see that the tan and tan will go. Then we are going to have the integral of sec theta d theta. Now, what is the integral of sec? So the integral of sec, if you don't know the integral of sec, kindly check out my video which I posted earlier, which I explained about the derivative. Okay, we know that. Okay, so now what are of the integral? So the integral of sec is just basically ln sec, let me write sec here, ln sec theta plus tan theta plus c. Now, after doing this is not the final answer because we are supposed to go back to our answers. Okay, like what we did in the previous examples. So here, what else I was supposed to do? We have the first guy which we made. The first guy which we had was we no longer need this, we only need that. So we have sec. So we want to solve for sec. So it's going to be sec theta is going to be x divided by 2. We know that this sec is the same as this secant is the same as what? If we say sec is 1 over sine. Therefore, sine, we can now say that since it's just the opposite, so we are going to have sine theta is going to be what? Okay, so sine theta is going to be 2 because it is the opposite of the reverse of that, so it's going to be 2 over x. Now let's draw our triangle. So if we are to draw our triangle here, let's just draw a simple one. So we have the theta. So we know that sine is opposite, so this is the opposite. So this is 2 over hypotenuse, that is x. So we can say this is b. So we know that c squared is equal to a squared plus b squared. So our c is x, so it's going to be x squared. Our a is 2, this is going to be 2 squared plus our b, we don't know the adjacent, so it's going to be that guy. So we're going to have that guy is going to be x squared minus 4 is equal to b squared, which is the same as b is equal to the root of x squared minus 4. So we have our b, which is adjacent here. So our adjacent is the root of x squared minus 4. Okay, now let's check. Tan is, we are saying, if we can check, we know that sine, we already know that sine is 2 over, so we're going to start now replacing there. It's going to be ln sec. Okay, we already know that sec here we had this. Sec is x over 2. So we're going to press x over 2 plus what of tan? So what is tan in this case? We know that tan theta is just the opposite of adjacent. So our opposite is 2. Okay, our opposite is 2. What of adjacent? Adjacent is the root of x squared minus 4. So we're going to replace that one. Now we have got 2 on top divided by the root of x squared minus 4 plus c. This is the final answer. Okay, let's work out the last example. We see how we can do it. So trig substitution is very simple, only if you know what to do. Okay, let's solve the last example. So the last example, which we're supposed to solve, is the integral over 1 divided by 16 minus x squared dx. So what we need to remember, those formulas which we had, the same as we had the constant. If we can check, we have the constant, which is a, minus x squared. It's the same as what we have there. So what else do we know now? If we know that that guy, we say that guy is the same as we're going to be replacing. So we know that our x squared is what? 16. What is our a? Our a is going to be 4. The square root of 16 is 4. What of x? Let's see. So our x is, since that formula, we know that it has come from the first formula. We know, then we are going to say that a is going to be a sine theta. But what is our a? Okay, what is our a? So our a is just basically 4. So it's going to be 4 sine theta. Now let's differentiate this, the same formula which we have. What is dx? So dx, the integral of sine is what? Is cos. Okay, so the integral of sine is cos. So it's going to be 4 cos theta d theta, because we are differentiating this in terms of theta. Now let's start now plugging the values. So we have got 1 on top, 16 remains constant, is going to be 16, minus, what is our x? Our x there, we have made x as 4 sine theta, but we square it, times, we do now times, we can extend that one times. So here we are going to have 4 cos theta d theta. The same thing what we did in the previous example, the same method which we are going to use. 1 times 4 cos theta, we are going to have 4 cos theta over here down, we are going to have 16 minus, let's now factor out that one. We're going to have 16 because 4 squared is 16 sine squared theta. Then you have d theta. Let's continue. We know that on top is going to remain the same over here. We are going to have now, we're supposed to factor out 16. So it's going to be 16 open brackets 1 minus sine squared theta d theta. Now where we have reached now there, let's continue from here. It's the same. 16 is going to come outside, but the square root of 16 is 4. It's going to be 4 cos theta, everything divided by, now we are going to say square root of that guy is 4. Then we're going to have 1 minus sine squared theta d theta. What else do we know? The integral of the 4 can go before we even continue there. The 4 can go. Then on top there, we're going to remain with what? Only we're going to remain with cos theta divided by 1 minus sine theta d theta. Now from here, we know that 1 minus sine squared theta is cos squared theta. So we're going to replace now there. We're going to have on top doesn't change. Down there, the square root of is going to be cos squared theta d theta. Okay. Now after doing that, what else do we know? What is the square root of cos squared theta? Okay. So the square root of cos squared theta is just cos. Then we'll go there and say the square root of, so on top there, nothing will change. The square root there is going to be what? It's going to be cos. So we're going to have cos theta d theta. So cos and cos will go, and we're going to remain with 1. So it's going to be the integral of 1 d theta. So 1 is the same as just, if you like, just d theta, just like that. Or if we want, we can just like the way it is. Now from there, what is the integral? It's the same as if we have this. Okay, let's create some space here. What is the integral of x? It's the same thing. Okay, if we have the integral of 1 dx, the integral of 1 dx is just basically what? It's just basically x. Okay, so even here, what will be the integral of that guy? So the integral of what we have there, the d theta, is going to be theta. There's going to be theta plus c. But we don't want theta in this case. What else are we supposed to do? We'll go back to our we made this guy, the x, your original x. We had x is equal to 4 sine theta. So we divide both sides by 4. We are going to find that sine theta is equal to x divided by 4. Let's make our triangle now. This is our theta. So, okay. So we know that sine is opposite. So opposite here we have x over hypotenuse. This is 4. Okay. Now, after knowing that, this is adjacent. So we know that it's going to be same as this is C, this is A, and this is B. So we know that C squared is equal to A squared plus B squared. Our C is 4 squared. Okay. Our C is, in fact, okay, let's finish this. Minus this one is going to be equal to A. A squared is what? So A squared is going to be what? X squared plus, what is our B? Our B is, we don't know the B. It's going to be B squared. Then we're going to have B squared is equal to 16 minus X squared. So if I want to find B, it's going to be B is equal to the square root of 16 minus X squared. Okay. But now, if we can check here, we only have theta. Now, you only do this when you want to find something else. But if we can remember, here we have sine theta is equal to, we have x over 4. We can make theta as subject of formula, and it's going to be sine the inverse x over 4. Therefore, we can replace this with what we have on theta. So we're going to have, the final answer is going to be, write it there, so it's going to be sine inverse x over 4 plus c. So this is the final answer. Thank you for watching this video. Have a blessed day.